So now we are going to discuss another problem based on the Coulomb's law, very important model. Here what is the problem is two particles A and B, two particles A and B having a charges Q and 2Q are placed in a smooth table with a separation D. A third particle, this is the third particle, is placed on table in such a way that the particles A and B remain at rest under the electrical forces. What should be the charge C? What should be the charge C? Where should it clamp to keep the A and B in equilibrium? To keep the A and B in equilibrium. So this problem can easily solved by using Coulomb's law. Okay. Here A and B having charges Q and 2Q. A and B having a charges A and B. These are the charges. What is the charge on A? Q. What is the charge on B? 2Q. So to keep A and B equilibrium, we must require another charge, that is C. So that is placed, the third particle C is placed on the table in such a way that the particle A and B remains at rest. That means this is the C, third charged particle. Okay, that is assumed as minus Q, negative charged particle. Whenever we place a negative charged particle, then only A and B are at rest. Okay, A and B are at rest. If you place a positive charged particle here, then A and B are not in equilibrium. So the third charge must be negative charge. The third charge must be negative charge. There is no chance of a positive charge. Right, now we calculate force acting on charge A. If we move this charge A towards C, it is attraction force. So force acting on A due to C along this direction. So force acting on A due to charge B, repulsion force. That is a repulsion force, FAB. These two forces are equal in they are opposite in direction. That means they may be cancelled. Here net force acting on the charge A is 0, possibility of 0. So A in equilibrium. Okay, right. So to keep a charged particle A at rest, forces are equal in magnitude but opposite in direction. Net force acting on the charged particle Q is 0. That means forces should be cancelled. So FAB is equal to, we calculate force acting on A due to B. Here what is the distance between A and B? D. What is the distance between charged particle A and C, let us assume it as x. Then what is the value of distance between C and B? D minus x. D minus x. So we write here 1 by 4 pi epsilon naught Coulomb's law, q into 2q divided by d square. Equation is equal to how much? 1. Right. FAC. Force acting on A due to charged particle C. 1 by 4 pi epsilon naught q into q divided by x square. Equation 2. If these two forces are balanced, then net force acting on charge A becomes 0. So the equilibrium of A is possible. Right. FAB is equal to FAC. Right here 1 by 4 pi epsilon naught q into 2q divided by d square is equal to 1 by 4 pi epsilon naught q into capital Q divided by x square. Right here 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught cancel, and also q cancel. Now the equation for capital Q is equal to 2qx square divided by d square. 2x square divided by d square. This is assume as let us third equation. So this is the equation obtained for the equilibrium of A. Now let us discuss equilibrium of B. That means there are two forces acting on B due to charge present at C and due to charge present at A. So due to this charge, there is an attraction force acting on B, that is FBC along this direction. Due to this charge, repulsion force is acting on B, so that is along this direction, FBA. Whenever these two forces are cancelled, then net force acting on charged particle B is 0, so that equilibrium of B is possible. Right. FBC is equal to FBA. FBC is equal to FBA. What is FBC here? 1 by 4 pi epsilon naught capital Q into 2q divided by d minus x whole square is equal to, what is FBA here? 1 by 4 pi epsilon naught 2q into q divided by, okay, distance between A and B, d square. Right. Here these are cancelled, and also here 2q also cancelled. Right. Now we write q is equal to, what we write here? Q is equal to d minus x whole square into q divided by d square. This is equation assumed as 4. Equation 3 is expression for q, capital Q, and equation 4 is also expression for capital Q. Right. Now equating these two equations. Equation 3 is equal to equation 4. Equation 3 is equal to equation 4. So 2qx square by d square is equal to d minus x whole square into q by d square. D square cancel. right, and also here q cancel. What we get? So 2x square is equal to 2x square is equal to d minus x whole square, d square plus x square minus 2 dx. Okay. Now bring these all terms to this side. 2x square minus x square plus 2 dx minus d square is equal to 0. So find the factors for this. X is equal to minus b plus or minus square root of b square minus 4ac by 2a minus b minus 2d plus or minus square root of b square, that is equal to 4d square. Okay, minus b plus or minus b square minus 4ac, 4 into d square divided by 2, right. Here x is equal to minus 2d plus or minus, here 4d square plus 4d square, 8d square. Okay, 8d square means here this can be written as 2 root 2d by 2, 2 root 2d by 2, right. Now x is equal to take common 2 minus d plus or minus d plus or minus root 2d This is the value of x. That means x means what? Distance of the third charge from A. So distance of third charge from A. Now right, here we have two values for x. Number one, x is equal to, if we take plus, that means we get minus d plus root 2d, that is equal to x is equal to, we take common d into root 2 minus 1. This is the value. That means position of charged particle x is equal to d into root 2 minus 1. Right. Next, we take another value. X is equal, if we take minus, x is equal to, what we get here? Minus of d into 1 plus root 2. 1 plus root 2. These are the two values of x. So if we take x is equal to d into root 2 minus 1, x is equal to d into root 2 minus 1. Okay. 2. Charged particle is placed in between A and B. Charged particles is placed in between A and B. That means here this is A, this is B, and this is C. So this is value of x. This is the value of d into root 2 minus 1. Right. If we take that value, then we will get the value of q is equal to how much? If we take x is equal to minus d into 1 plus root 2, then the charged particle is placed on the left side of A. Left side of A. That means here this is A and this is B. This is the third charged particle C. This value is d minus d into 1 plus root 2. Left side of A. So there are the two possible values. By substituting these values in 3 or 4. In 3 or 4, we will get value of q. We will get value of q. Right. Now substitute these values. Substitute these values. We will substitute these values in 3 or 4. Now we will substitute these values in 3. Substitute these values in 3. Right. First 3. What is the third equation? Q is equal to 2q x square by d square. So q is equal to 2q. What is the value of x here? Now first we substitute root 2 minus 1 to d. Root 2 minus 1 into d whole square by d square. So here what we get here? Q is equal to d square cancel. We will get the value of q, the third charged particle to q is equal to root 2 minus 1 into root 2 minus 1 whole square. This is the one value. So the charged particle is placed in between A and B. Then the value of q must be this one. Okay. Now we will take another value. What is that another value here? Q is equal to 2q. What is the another x value? Minus d into 1 plus root 2. So here minus d into 1 plus root 2 whole square divided by d square. Right. Now q is equal to d square gets cancelled. Now here 2q into root 2 plus 1 whole square. So if charged particle is placed on the left side of A, then the value of q is this much. Okay. So there are two different values of q we obtain. This is the problem.